Today's lesson is going to be going over solving linear systems by graphing. What we're going to be doing is we're going to be attempting graphing different linear functions, and their point of intersection will become the solution. Once we have the solution, we are going to take a look at the bottom of the back of the worksheet. You would find the solution and put the corresponding letter here to answer the question. And the question is, what do sprinters eat before a race? So I'm going to model how we would fill that in as we go through examples. The directions say that we want to solve each system of equations by graphing. We're going to graph both of the lines and write the coordinate where they intersect. Now, for number one, when I want to graph these linear functions, the equations are written in what's called slope-intercept form. Y equals mx plus b. Again, that's slope-intercept form, where m is the slope, b is the y-intercept. Slope is also known as rise over run, and the y-intercept is the point on the y-axis that the graph would cross through. The first equation I have is y equals negative 1/3 x plus 5. I'm going to place my y-intercept of 5 on the graph first, which is right here. And then I'm going to use my slope to get my next point. Slope is rise over run. Because it's negative, that would move the function down or left. So I could move from this point. I could either go down 1, right 3, or I can go up 1 and left 3. The more points that you plot, the more accurate your graph is going to look. So I'm going to do this a couple more times. I'm just going to keep extending this, going down 1, right 3. And over here, I'm going to keep going up 1 and left 3 just a couple of times. It would be helpful if you had a ruler or something with a straight edge that you could use to connect your points. And now I'm going to graph the second function. Once again, it is in slope-intercept form. For the second equation, the y-intercept is 9, which is right here. And the slope is understood to be 1. And it's a positive 1, so I'm going to go up and right, or left and down. And we want to keep drawing the point so I can see where it's going to intersect. Going left and down, I'm going to continue. I can see a point where they overlap. It's right here. That's enough for me to get a good line. So the solution would be their point of intersection, meaning our answer is going to be written as a coordinate, and it's going to be this point right here, which is located at negative 1, 2, 3, so negative 3 for the x, and then 1, 2, 3, 4, 5, 6 for the y value. Next, let's do number 3. Number 3, I'm going to do this a little bit faster now that we're getting the hang of it. The first equation has a y-intercept of positive 8, and it has a slope of negative 2. Because this is a whole number, technically, that means that it's negative 2 over 1. So I could either move down to right 1 or up to left 1. Remember, the more points that you plot, the more accurate your picture is going to be. And then I'm going to use my ruler to help me out. There's the first equation. The second has a y-intercept of negative 3. So I'm going to go down 3 on the y-axis. and then it has a slope of 3 over 4. So rise over run, that's up 3, right 4. So that's my next point that I would get using the slope. Once again, up 3, 1, 2, 3, right 4, 1, 2, 3, 4. And then you're just going to, that's enough points where I can get the general shape by connecting them. Because I can see where the point of intersection is at. You want to write your answer as a coordinate. Remember, a coordinate is x comma y. The x value of this coordinate is 4, and the y value is 0. So 4, 0 is our answer. 5. Why don't you go ahead and pause the video to draw your graphs? So now we're getting to the point where I recognize that you can graph linear systems. My first equation is in purple, my second is in red. But now we need to talk about what happens when we have two parallel lines. Because typically, to write our solution, it's their point of intersection. Two parallel lines will never, ever intersect. So when you have two parallel lines, that means there is no solution. Because again, they will never have a point of intersection. An indicator that it's no solution, again, is parallel lines. That's the notation for parallel. And it also occurs when you have the same slope. So having the same slope is what made it become parallel lines. So if you ever notice their slope is identical, you could just instantly identify it's no solution. You don't even have to graph it. So let's fill in the letters from what we have so far. We said number 1 was -3, 6. If we look at the back, -3, 6 is all the way over here, which is t. So 1 is t. Number 3 was 4, 0. If we take a look here, 4, 0 is h. So 3 is h. Here it is right here. And then lastly, we found out number 5 was no solution. No solution corresponds to t. So 5 is t. This is what we have so far. Number 12 is a little bit different because both equations are not already written in slope-intercept form, which again is the y equals mx plus b. The first equation is, but the second equation isn't. So what you want to do is rewrite our second equation in slope-intercept form. So I would do that by adding 2x to each side, which gives me 3y equals 2x plus 3. And then divide each side by 3 to get y by itself. So y equals 2/3 x plus 1. Because 2 divided by 3 is 2/3, 3 divided by 3 is 1. You have to divide each term by the value. Now go ahead and pause the video and graph your equation, then hit play. If you tried graphing them, you may have noticed for the first equation you have y-intercept of 1, then the slope of 2/3. So up 2, right 3, or you could have moved down to left 3, either way. That would give you your line, which I'm going to use a ruler for. When you went to graph your second equation, you may have noticed, hey, y-intercept of 1, slope of 2/3. This is the same exact equation. So the same equation. That means When you would go to graph the second one, it would overlap the first one perfectly. That means they have multiple points of intersection. In fact, because they overlap perfectly, there are infinitely many solutions, which we could abbreviate as IMS. Infinitely many solutions. Infinitely many solutions corresponds to an S. So on the front of our paper, this was number 12. So 12, we're going to put an S. Let's do number 13. 13, we have our first equation, which is in slope-intercept form, but our second equation is not. So what we're going to have to do is get it in that form. I just feel like that's the easiest way. If you know your different rules, so we have slope-intercept, and we have point-slope, which is what this is, you'd be able to graph it that way, which is fine. If you want to use point-slope, go for it. It just means you get the point. So our point is going to be 2, -8, and then our slope is -3. I would go ahead and just distribute the -3. So I have y plus 8 equals -3x plus 6. And then subtract 8. So y equals -3x minus 2. Because then I could go ahead and graph it. Here's -2 right here. A slope of -3 down 1, 2, 3, right 1. Or you could have moved up 3, left 1. I'll do that a couple of times. That's enough to get you your line. The first equation had an intercept of 3, so that's right here. And then it had a slope of 2. So up 2, right 1, or down 2, left 1. You can already see where the point of intersection is. I need to draw my line first. The point of intersection here is -1, 1. Because it's x comma y. -1, 1 on our list is right here. It is n. So I'm going to go back and put n for number 13. So far to the question, what do sprinters eat before a race? We're filling in the gaps. The rest of this worksheet is your homework. Go ahead and attempt it, then upload a clear picture of this worksheet when you are done.